Okay, today's concept is about systems of equations. So solving a single equation with one variable is something I think that most people are pretty familiar with if they have x plus 5 equals 8, for example. If I have x plus 5 equals 8, I can subtract 5 from both sides and x is equal to 3. I think a lot of people are pretty confident with that. But today we're going to talk about what happens when we have two variables. So having two variables makes it pretty impossible to solve if we have just one equation. But if we're given two equations, then it's doable. So if I look right here, and these are both linear equations. Let me make sure that's not cut off anymore. Okay, so we have two linear equations, x plus 5 and 2x minus 3. And both of them are equal to y. Well, if this equals y and this equals y, then these two things have to be equal to each other. So x plus 5 has to equal 2x minus 3 if they're both equal to y. So then, now I have an equation with only one variable. So this is solvable by getting my x's on one side. So I'm going to minus x from each side. So I have 5 equals 2x minus 1x is just x minus 3. And then I can add 3 to both sides, which is 8. So our x is equal to 8. And now I also have y to solve for, but once I know what x is, that's a piece of cake because I can just plug x in. So if I plug 8 in right here for x, 8 plus 5 is 13. So x equals 13. And the nice thing, or y equals, I'm so sorry, y equals 13, because 8 plus 5 is 13, y equals 13. So the cool thing about this is I could plug this x value in for either equation. So I could plug the 8 in here. 2 times 8 is 16, 16 minus 3 is 13, and I'd have the same answer. So you can pick which equation you prefer to plug it into. It's also a really good way to check your answers. If you plug it into both equations, you should get the same answer both times, and if you don't, then you know you did something wrong. So if I look at number 2, it's the same idea. Y equals this and this, so those two things have to equal each other. So on this side, I'm going to minus 3x. So these cancel, and I have 2x plus 2 equals negative 8. And then minus 2, these cancel, and 2x equals a negative 10. And then I can divide by 2, and x equals a negative 5. And if I plug that in, 5 times a negative 5 is negative 25, plus 2, y is equal to a negative 23. So that's when we're dealing with two linear equations. What we're going to be talking about mostly with this concept is dealing with one linear equation and one quadratic equation. So that's what these next 6 problems deal with. So the idea of them is the same. Our solving method is just a little bit different. So it's still y equals this and this, so these two have to be equal to each other. So I have x squared minus 9x plus 18 is equal to 4x minus 12. So this time, where before I was trying to get my x's on one side and my numbers on the other side, this time I want everything on the same side. Because of this x squared, I think factoring is going to be my easiest method to solve this. So I'm going to subtract 4x from both sides, and I'm going to add 12 to both sides. So then these cancel, So I have x squared, negative 9x minus 4x is a negative 13x, and 18 plus 12 is 30, and that's equal to 0. So I'm going to go ahead and find my a times c so I can factor. So I have 1 times 30 is 30, and my b is negative 13. So two numbers that multiply to 30 and add to negative 13 are negative 10 and negative 3. So this factors to x minus 10 and x minus 3. And then to solve that, I'll set each of those equal to 0. So I have x minus 10 equal to 0, x minus 3 equal to 0. So I can add 10 to both sides, and x equals 10. Add 3 to both sides, and x equals 3. So this time I have two x values, 10 and 3, which means I'm going to have two y values because I've got to plug both of these in to solve for y. So I'm going to use the second equation just because it seems a little bit easier. So I'm going to plug a 10 in. 4 times 10 is 40. 40 minus 12 is 28. So y equals 28. Then when I plug my 3 in, 4 times 3 is 12. 12 minus 12 is 0. So y equals 28 and 0. So pretty much all of these quadratic problems you're going to be able to solve through factoring. So let's try that exact same process one more time, and then I'm going to let you try the other ones and I'll give you some answers so you can check yourself and make sure you're doing it right. So on number 4, I know that this is equal to this. So I'm going to say x squared minus 20 equals x plus 10. So I want everything on the same side, and I want my x squared to be positive, which tells me I want to move these over to here. So I'm going to minus x and minus 10 from this side. And there's no x term over here. There's an x squared term and there's a regular term. So I'm not going to be able to combine my minus x with anything. But I can minus 10 from negative 20. So I have an x squared and minus x. Negative 20 minus 10 is a negative 30. Equal to 0. So I have an a times c is negative 30, b is negative 1, and two numbers that multiply to negative 30 and add to negative 1 are negative 6 and 5. So this factors to x minus 6 and x plus 5. Now if I set each of those equal to 0, I'm left with x equals 6 and x equals negative 5. And then as I plug those in for x, 6 plus 10 is 16. Negative 5 plus 10 is 5. So x equals 6 and negative 5, y equals 16 and 5. So the rest of these problems, rather than bore you by going through them all, I'm going to let you try them because the process is the exact same. So you start by setting your two equations equal to each other, and then get everything on the same side, factor and solve for x, plug x back in, and solve for y. So I'm going to just briefly solve them without much explanation so that you can check your answers. So this one, once I get everything on one side, I have x plus 14x plus 24, which factors to x plus 12 times x plus 10. So x equals negative 12 and negative 10. And I don't expect you to be following my math. I'm just getting the answers so that you can try it and then check your answers. So then y is equal to negative 12 times negative 6 is 72. 72 minus 9 is 63. Oh, I am going far too fast because I just factored this wrong. This should be 12 and 2, not 12 and 10. So 12 times 2 is 24, and 12 plus 2 is 14. My mistake. So this should be a negative 2, not a negative 10. So then when I plug a negative 2 in, I have 12 minus 9, which is 3. Okay, on number 6, x should equal negative 6 and 2, and then y equals 48 and negative 8. So try that one, and there's your answers to check you. And then 7 and 8, I scroll real quick. This x is equal to 11 and negative. I shouldn't do these in my head because it's making me. So I have x squared minus 9x minus 22. So yeah, x is equal to 11 and negative 2. And then y is equal to 61 and negative 4. So try that one, and there's your answers to check. And then on this side, I have x is equal to negative 6 and negative 4. Y is equal to negative 5 and negative 7. And this one I'm actually going to talk about really quick, because when you plug this negative 6 back in for x, you have a negative negative 6, which actually makes this a positive 6 minus 11. So that's where the negative 5 comes from. And the same thing with the negative 4. You have a negative negative 4, which is a positive 4 minus 11, which is negative 7. So go ahead and try those last 4. Sorry for that brief mistake on number 5. But try the last 4 and you can check your answers with my answers.